All right. So today's topic, I gotta check something. I don't think my recording's working here. All right, we should be working now. All right, today's topic, economic analysis of wood energy projects and case studies. Wrong way. So what we're going to kind of do is I'm going to show you what I call a kind of a rapid analysis to try to sort out projects that work and don't work. I'm going to kind of give you a cost list of some of the things to look for or find when you're doing a project. The other question is whether you do logs, chips, or pellets. So I'm going to give you something from the Forest Service, but it's not held in stone. It's just their experience on what works and what doesn't. We got some tools to do more in-depth analysis. I'll run you through some of those. I'm going to highlight a few case analysis, and then I'm going to show you where there's more. And we're going to go through the grants and loans that might be available to help offset the cost of the projects. And there's some resources as we go along as well. So the first thing when we're looking at a project is to see if it makes sense from a wood or a fuel source standpoint. So the chart I've got in front of me is something I put together to compare fuel costs, and the last column is the most important one here. This column here, because it equalizes everything into a million BTU basis. So based on the costs that I have, so I've got some costs in here. Yours may vary, and it varies with the years. So the way this chart goes, it uses an energy content, it uses thermal efficiency of the combustion unit. So the ones that are in parentheses are the ones used for this analysis, a cost, and then it comes up with a cost per million BTUs. So if you go to this chart, I'm going to put a version of this up on our Wisconsin Wood Energy site, so you can actually put in numbers and change them if you want. But if you go to this first and you find that, say, like we have natural gas and we want to use wood chips, well, there's only 30 cents a million BTUs or 39 cents a million BTU difference. It's going to be really hard to cost justify the equipment in that case. But if you were looking at wood chips and say heating oil, now I've got $12 a million BTUs different roughly. So that makes the project possibly more likely to work. So that's kind of the first step. Now, how did I figure these costs? Well, this next, hang on a minute. This next slide here shows how we did the cost. So you've got a million BTUs. Let me change my pointer here quick. So we want to get dollars per million BTUs. So we have the dollars per unit. So that'd be dollars per gallon, dollars per therm, and then we're going to do a million BTUs, and we divide that by the energy content per unit times the thermal efficiency of the combustion unit. So the example I've got down here, it's $2 a gallon propane, and the red is 80% efficiency. So then I come up with $27 and change per million BTUs. So that's how that chart was put together. So a rapid assessment process. First, you need your fuel bills. You need the energy efficiency of the heating appliance you currently have. So this can be done through testing, or maybe you can get it off a spec sheet of what that might be. If it's an older unit, you may want to discount it for its age. And then the formula is the fuel you've used times the energy per unit. So this box up here shows, up in the upper right, shows my BTUs per energy content. So put that in. So and then times the efficiency of the unit. So my example here is I'm using 2,500 gallons of LP gas or propane. My boiler efficiency is 75%. So it's 2,500 times 9160 BTUs per gallon, which I got it from the table up here, times 75% efficiency. So the amount of heat that ends up in the structure that I'm trying to heat, or the process I'm trying to heat, 25% of that's wasted, 75% is usable. I come up with 171,750,000 BTU. So M BTU is million BTUs, or sometimes it's BTU. So then the next step is to choose a fuel and the appliance, and we need, again, the energy content of the fuel and the heating system efficiency. So say you're going for a wood chip boiler, or well, let's use wood pellets as I've done here. The usable heat, which is what I just figured on the previous page, divided by the energy unit per unit of fuel, divided by the efficiency of the heating unit or combustion appliance. So here I've got wood pellets at 8,400 BTUs per pound, a boiler efficiency of 80%. So it's my 171,750,000 BTUs divided by 8,400 BTUs per pound, divided by the efficiency at 80%, gives me 25,000 pounds of pellets I need. If I divide that by 2,000 pounds per ton, I end up with basically 13 tons of fuel that I need. In the box down here is just some representative numbers. If you're buying something like wood pellets, it should have it on the label as to what the efficiency of that is. So then the next step, we want to know the cost difference. So the next step is to obtain a quote for my fuel wood and calculate the savings. So here I've got my propane at $1.30, or 2,500 gallons at $1.35, and that was the average price so far this winter, for residential anyway. It's $3,375. And then I've got wood pellets. If you get it at a big box store, it's going to be maybe $240 a ton. If you buy it in bulk, it's maybe $180 a ton, depending on the delivery distance. So I settled on 200. So we take our 12.8 tons times 200, gives us $2,560 per year. I take in the difference of that is a little over $1,000. So right here is a checkpoint. If maybe I want to pay for whatever I buy the unit in 5 years. So if I take 5 times this number, I'm going to end up with a little over $5,000, basically $5,300 that I can spend on a unit and pay it back in 5 years. So that's a check. So the next step is to obtain a cost for the unit. So I got the appliance, I got the chimney, electrical connections, plumbing, fuel storage possibly. I may need some accessory equipment. In larger situations, you may have to have engineering study to decide what size all this stuff is. There might be a building involved, etc. And then you got to have permits if it's a larger system. So you need to gather all those costs together. And then we're going to I'm going to look at how this pans out. So the first question is, are your fuel savings positive? So we already looked at that. The next step is what the simple payback is. So I take all those investment costs, so all these costs, and add them up. So it's investment cost divided by annual savings. So if I was going to spend $5,000 for a unit and I had $2,500 in savings, that's basically a 2-year payback. The next question to look at is my simple payback less than the life of the equipment. If I end up with a 12-year payback and the average expected life of the equipment is 10, you're never going to pay it off because the chances are you're going to have to replace the equipment before you ever pay it off. So if you get through all that, then the next step may be to do a more in-depth cash flow analysis. So a net present value analysis possibly, or some other type of financial analysis, and that may be based on the type of business and what your accounting people like to use for an assessment. One of the ones that I use kind of to figure out the cost, annual cost, is called the equivalent annual cost. So this uses a discount rate or the interest rate and the expected life or payback period of the equipment. So you take, you're going to do a net present value analysis or your investment cost, depending on how you want to do it. And then you look up on a chart for your capital recovery factor. And these are in economic, if you get an economic book, it's going to have it in there. It's called a capital recovery factor. And it's going to be based on the years of life and the discount rate. And you put that in this formula and you get a good number. Now, to that number, you have to add your annual maintenance costs. So, getting it serviced, parts, etc. You'd have to add that to this cost, because what I'm after is my annual cost of ownership. So the example I use down here, I have a $100,000 investment. Expected life is 20 years at 7%. I got $2,000 in maintenance costs a year, and I'm assuming the salvage value, which is another factor in doing the economic analysis, is 0, and that's just to simplify this. So I got $100,000 by the factor I looked up in a table, 0.0944, plus my $2,000 in annual maintenance. So I come up with $11,440 per year. So that's my annual cost of ownership. Now to that cost, I need to add my fuel cost to determine the total annual cost of a unit. But that's kind of the rough way I'd go through this. So I kind of went through some of the costs before, but some of the other costs you could get into, especially the bigger system, is you've got your feasibility studies, engineering costs. To basically, if you've got a large system, they're going to have to lay it out. They're going to have to figure out how big the feed system has to be, how big the storage, how big the building has to be to put it in. There may be foundation design things you have to do, depending on how big the system is. So those would all have to be figured out. If you're a larger system, you may need you may need a zoning permit or a building permit. You may need an air admissions permit from the DNR. You're going to have your equipment costs, of course, freight to get it to your site, and somebody to install it. Then there may be commissioning costs to get maybe somebody from the company to come in and do the startup, setup, etc. So those are all costs that you need to be aware of when you're figuring out if the system is going to pay for itself. Now the question is fuel costs, or what type of fuel to go with. So this has a lot to do with boiler capacity, what's available, fuel availability. So wood pellets you can chip in from quite a distance because they're denser. Wood chips are very light and bulky, so those you really need to source probably within 50 or 60 miles away, and the same possibly with logs. The other question is labor. If you're going to cut your own firewood, do you have enough labor to cut the 20 cords you might need for a big system? How are you going to store it? Does it have to be stored undercover? Do I need a building? The capital costs of the equipment, emission requirements, truck access. If you're going to get stuff delivered by the truckload, like wood chips, you may need truck access to that. So those all come in and are factors. So the Forest Service, through their experience in doing wood systems, has found that if you're below 35,000 gallons of propane or 22,500 gallons of fuel oil, you're probably better off with wood pellets or cordwood. If you're above that, then any of those will work. Now, having said that, there are lots of new technologies that are coming in for wood chips especially, with lower capacity units. A lot of the cost in wood chips is the material handling system. So that's what adds the cost, and you have to a lot of times have a larger system to be able to justify that. But these numbers aren't cast in stone, but kind of a guidance, a little bit of guidance. So we're going to look at some analysis tools. A couple of these have some issues at the moment, but we'll go through them anyway. So RET Screen is a product that's developed by Natural Resource Canada. It's well maintained. It's basically a spreadsheet. It takes a little bit getting used to how to use it. It's a little bit complicated. I'm not going to go through it today. If you get online, you can find they have courses and tutorials on how to use it. But it's a very good tool, and it brings in weather data. So if you have a building, you can simulate the building, and it'll bring in the weather data to help you figure out your fuel costs in some cases. The two I'm going to go through in a little detail is the Michigan Wood Energy Calculator and one that was developed, a Wood Energy Finance Calculator that was developed by the University of Minnesota. So the first one's Michigan Wood Energy. You can find it at michiganwoodenergy.org, and it's pretty simple. There's eight inputs basically. You got a contact information, your location, an email, because it's going to email you the results. The type of facility, pretty generic. Boiler size, so it's good to know what you have now for this. The type of fuel you currently have and the price, your annual fuel use, and then the cost of wood fuel. So typically it's going to be wood pellets or wood chips. This really doesn't do cordwood. And then the interest rate you want to use. It assumes no grants. If you were in Michigan, it knows what grants are available in Michigan, but since we're out of state and you've got to pick that as a location that you're out of state, it doesn't know what grants are available. It assumes 10-year financing. Wood chips if you're over 3 million BTUs, wood pellets if you're under. It's going to assume that you're going to use 95% wood and 5% of your current fuel. And the wood boiler is basically sized at half the existing boiler for this site. So in that case, you're going to probably want thermal storage to cover peaks and valleys, or your current boiler will act as your backup. So I don't have a screenshot of the inputs, but this is what the output will look like. It basically gives you a summary of your costs here, and your wood pellet cost, what the existing, so this is 95% of your heating, 5% of your heating. It gives you your, you got some additional maintenance costs. I think you can enter that as a number in there if I'm not mistaken. But it calculates out your annual savings and your net cash flow. And it also calculates the payback. So the simple payback is up here in the top It's 8.1 years for the example that was put in here. So that's just an example of what that unit does. Now, it assumes a capital cost for this, or the boiler cost. We found that sometimes these sites are kind of way off. So sometimes you're better off trying to figure out what your own costs are versus relying on the site for that number. The next one is a Minnesota Wood Energy Calculator. It's at woodenergyproject.com, and it has more detailed inputs. You can change the capital costs. You know, it'll assume some costs, but sometimes what happens, it puts too high costs in there, and on both of these tools, sometimes you'll have a cost that's out of whack and it makes the project look feasible when it really is. This particular tool has some errors. I've been through it in the last few days, and I'm not going to tell you what the errors are, but it just has some errors that they're working on. I can tell you that. So hopefully by summer it'll be fixed. But I want to take you through it because it's laid out very nicely. So here's my screenshot of you pick the state, your county, the type of fuel, the cost for the fuel. I've got the gallons per year down here. It calculates out the million BTUs per year. Actually, we got these highlighted here. I forgot about this. You got hours of operation, and you have to select the months you want it to run. So here I've got 5 months, January through March, November, well, November through March. And then you can do the substitution percentage down here. So 80% is actually, if you're looking at sizing the system, sizing it for 80% substitution is actually pretty economical value for a good rate of return. The next page, you pick the type of biomass you want to use. It's going to assume a moisture content. Let's see. Then it's going to calculate out it's going to assume a boiler cost in here. You can click this little box here, and then it'll let you put in your own. If you've got building costs, you can put in there, labor costs. So say the cost for maintenance, daily maintenance, and then maybe annual repair costs and stuff. So it calculates out the total cost of the system here. So this is the next page down here. You put in your cost per green ton. So basically green wood, so we're not talking about green as in really wet wood. It's what the moisture content is purchased. So if you're buying wood pellets at 6% moisture, that's the cost you put in here. And what it does, it figures out the cost as if there's no moisture in here for its calculations. Let's see what else needs. So it figures out the amount of fuel you're going to use and your annual fuel costs over here, and it'll calculate the annual savings. This is a summary of your finances. So we've got the total system cost, other contributions, that could be grants. Say you've got an energy incentive to put one of these units in, that's where you'd enter it here. Your discount rate or your interest rate on your loan, and the lifespan of your loan or the equipment. So you'd put all that in. And then it's going to figure out your total finances here. So it goes through all the calculations, and basically it figures out your net present value, which in this case is negative, and basically this project will never pay back. I only had $600 a year in savings, and I got $24,000 in costs. So that's just an example. Don't use that as the fact that it will or won't work, but I'm just showing you kind of how the system lays out. So I talked about RET Screen. There's the URL for it. Basically, you download the spreadsheet, and then you can do things through. It's very good for larger systems, especially or district heating type stuff, and they do have some case study type things, and there's a few default values, but you have to put in quite a bit of things. Oh, I do have some of the screens. Okay. So in this case, you would pick the type of project. So heating biomass, this could be a CHP system. The type of heating value reference. So this shows some of the screens. So if I got a building, I'd put the square footage in here, the heating load for the building. So it's BTUs per hour per square foot. If I want domestic water in here as a percentage, it's going to figure out how much energy I need. You put in your fuel types and your efficiencies here, and the cost of the fuel, and then it comes down and figures out those costs. This is where you'd put in the your cost of equipment. So I've got 60,000 BTUs in here for a system, and this is the system size here. So those are all numbers that you'd have to enter. Let's see, what do we got? So this is greenhouse gas emissions. Most people don't worry about that too much. And then here's where you'd figure out your finances. So I got 15-year project life, 100% debt ratio, 5% interest rate, 10-year debt term. So it's going to figure that out, and then it's going to show you your cash flow based on that in graphical form. But it's a nice tool. It can get a little more complex. There's two methods you can use on that. Load analysis and a energy analysis model. And they also have a sensitivity model. So this is the second type of model, load-based system. And basically you just go through and answer the questions, and it'll spit out. And it has, I think I've got a graph of the sensitivity. So there's the cost structure, similar to what we previously showed. It gives you yearly cash flow numbers. So it's just in a little different format than what I previously showed you. And then it gives a sensitivity analysis. So here's fuel costs versus initial costs. Fuel cost. Oh, I guess I got the same thing twice there. Oh, this is, I'm sorry. This is base case, is proposed case. So it just shows you, and then based on your percentage of change of the initial cost. So here I did a 0, +5, +10, -5, -10. And then you could do the same thing with your interest rate cost to see if it's positive or negative. So those are some of the tools that are out there to help with analysis. There are some resources out there. This is a good one. It's a thermal wood energy handbook. So it goes through different issues that you can run into in launching a project. And this is on the wood energy. So it's on the Michigan Wood Energy Analysis Tool page. It's part of that site. Here's some other resources. And these are, I believe, all at the Biomass Center. So it's biomass.org resource site. So one on wood pellet heating, for small commercial industrial or institutional systems. They've also got a wood chip one. And then here's one that's feasibility of Wisconsin schools heated with wood, which is was done in 2008. Most of the systems were put back in the mid-'80s that they analyzed, but just to give some analysis. So now let's look at a few case studies here. So here's a few. Some of these are actually on the wisconsinwoodenergy.org, and there's many more. So this one is Forest Springs. It's a Christian camp facility. It's currently heated with natural gas. It was put in '94. They're a little unique because they have 500 acres of managed forest, but it's basically a residential type structure, meeting rooms, etc. Type facility. So what they did is they were doing an expansion, a 34,000 square foot expansion, and they wanted to use wood. So they'd already have previous experience with a garn unit, and I've got a picture of that, I think, in the next slide. So they put a second one of those in, but they used wood from cleanup and trails and down trees, etc. They viewed it as free, and we'll talk a little more about that, but to me that's kind of dangerous to do, but we'll talk about that in a minute. So here shows some of the plumbing to go, the heating system to go to their buildings. This is the garn unit here. It's a firebox and water. So the firebox, I believe, is insulated on these. This is a burn tube down here. Gets up to about 2,000 degrees to burn any pyrolysis gases as it leaves. They've got, they call them cribs that they stack their wood in and then bring it in with a fork truck. But the boiler itself here was about $20,000 plus installation. So they can fill this up twice a day typically, and let it heat the water. They put it in a building that's has the boilers and fuel storage, and it also has a water system for sprinklers. It's all incorporated in the same building. So here's the financials on this one. The current fuel was natural gas. They went to wood. Last year's heating bill was $175,000. The new annual bill is $7,200. Now, that's one of the reasons that this project works so well, because they're only allowing $50 a cord for their wood. To me, that's really not, somebody's got to go out and cut it, chop it, haul it. You got machinery involved. Now, maybe they get volunteers to do the labor, but you still have costs. And the other question is, what happens if you have to pay for it? This is artificially low compared to what it should be. I suggest using either a wholesale number or a, what you can buy it for, as a safe number to really tell whether this is a good investment for you. But here's the cost of their equipment. Looks like the total expense is $133,000. They did have a loan on it, 5-year loan, and they looked at let's see. Well, I'm not. Should have looked at this before. This number seems low because it. Although I guess that loan wouldn't be a lot of money, but it's the same number as up here. But anyway, so they got a 0.8-year payback. Very good. That's a no-brainer to do if it's truly that good. Here's another system. This is a Cherry Hill school in Iron, um, Minnesota. They were looking at the future and that they were going to have to expand, and I believe they had an old heating system, so they wanted to offset 30% of their fuel bill, which was about 60. Well, the 30% would save 60,000 gallons of LP gas annually. So they put in I believe it's a pellet boiler. They're using about 270 tons of pellets a year. They've got a storage facility with the boiler in it. Anticipated payback was 5 to 6 years. So their storage can handle shipments of, I think you get about 20 to 22 tons on a semi-load of pellets. So their storage facility is just a hair bigger than what a load of pellets would be. Ideally, you might want the storage unit a little bigger. So here's their bin for storage and the building to house the boiler. So this shows some of the particulars on that. It was an 88% efficient boiler. They had propane, which is 90%. When this was done, they were paying $160 per ton for wood pellets. So they had a cost savings of about $38,000 a year. Here's another one. This is another pellet boiler. This is a 9-mile recreation area outside of Wausau, Wisconsin. So this is a community center. It's in a county wooded area or county rec area. It's about 5,500 square feet of building. They had 2 hot air LP furnaces that are 20 years old. So they replaced that with a pellet boiler system. The cost of the project was $35,000. They had incentives of $20,000, so they had $15,000 in out-of-pocket costs for this, and the estimated cost of $2,000 a year. So it's about a 7-8 year payback in this case. They figured they were saving about half their fuel bill previously. So it's a nice compact unit. Fuel storage would be outside the building to supply the wood pellets into this unit. Oh, actually, I think this is a part of the feed system right here for the pellets coming in. Here's another one that I put together. It's Muscoda protein products or Meister cheese. This is a large system. So is the offset natural gas. It's a 400 horsepower wood boiler. It's using wood chips. The initial cost was 1.7 million. You can see it's a fairly large facility. This was used for evaporating water to make dried whey powder and for process heat for the cheese plant. They got 2 grants. One was $35,000 from the Focus Energy Program, which is Wisconsin's energy efficiency program, and $430,000 was from USDA, which I'm assuming was a REAP grant, Rural Energy for America program. So the estimated savings was $390,000 a year. So you can see that's a little over a year payback in this case with the grants they got, or actually 2 years, a little over 2 year payback. So there's more case studies at WisconsinWoodEnergy.com. I highlighted this one before, the Wisconsin schools. There's another one that's got case studies, and Michigan statewide wind energy team also has some ones on it, and they've got one that's actually I probably should highlight that one. They're using the wood energy to run a absorption chiller to provide air conditioning for a health care facility. And then the Biomass Energy Resource Center has additional ones. So if you're looking for a project that's similar to what you want to do, you might find one at one of these sites. So now I want to look at grants and incentives. So there's a number of different types. There's utility ones, and for biomass here in Wisconsin, there's none through the utilities. It's through our state program, which is the Focus on Energy program. And then we have a federal program. So I'm kind of step through the different programs. So Wisconsin Focus on Energy program is our state energy efficiency program. Most utilities in the state are on this, but not all. But if you're using natural gas, they would be on it. And for them to provide a grant, you must be using natural gas, and your project must have a positive cash flow. And one of the problems we run into is most projects that would involve natural gas at this point would have a negative cash flow because natural gas is lower cost or almost the same cost as wood chips. But so in recent years, very few projects gotten funded, but they have a call for proposals once a year or twice a year, and you can find those at the booksenergy.com, and it's going to be under RFPs or RFPs is what it'll be under. For federal grants, which would be other options, they have grants, guaranteed loans, and tax credits, and then a combination of guaranteed loans and grants. So the first one I'm going to highlight is called the Rural Energy for America program. It's been around for a number of years now. For renewable energy projects, it's up to $500,000. They also do energy efficiency. Note they have a special category for projects that are under $20,000. The minimum for a project for renewable energy is $2,500. And you can ask for up to 25% of eligible costs. You have to be considered a small business, so that's under 500 employees, although it does vary a little bit with the type of business. And there is a limit on gross receipts. So if you go to their site, they're going to send you to another site, and there's some limitations, but most rural businesses are going to qualify. Now they did change it used to be that if you had to be in an area that had less than 50,000 inhabitants, and now they're changed it and it's greater than 50,000 inhabitants, but they changed the way they do it. I think most places in Wisconsin will qualify, but we might find some areas that won't if you're way off in the boonies. But again, it's energy efficiency and renewable energy projects. So they have grants, and they also have guaranteed loan guarantees. So loan guarantees up to $25 million with a $5,000 minimum. Can be up to 25% or 75% of the cost of the project, and guarantees up to 85% of the cost of the project. Again, it's for small business only. And if you go to this link, will take you to program details. The other grants we have or incentives are through the U.S. Forest Service Wood Innovation Grants. So these are up to $250,000 for final engineering on a project. So that's, sizing the equipment, the building, the footings, the grading, all those kinds of things that have to be done out ahead of time. So that's one. The other would be that the statewide wind energy team also does free feasibility studies. So that's kind of a pre-engineering study. to look at, and those we offer at no cost to the owner to look at those. So if you've got a project you're interested in looking at, it can be just thermal heating, it can be combined heat and power, contact me and we'll get you in touch with, we'll either do the feasibility study for you or we'll send it off to the Forest Service to have them help us with it. So another way to help pay for a project is the government has a target for green power purchasing, so they want to buy a minimum amount of renewable energy for their facilities. So this can be electric or thermal, and sometimes they will just buy the renewable energy credits for those, or the electricity. But you can go to this link on the bottom here and find more information about that. But that's a possible source if you're doing a project and you want to sell the output of that project. So if it's thermal, it's probably going to have to be co-located with a federal facility. But if you're selling electricity, that could be anywhere where you're wielding it on the grid to them. The other has to do with financials of cost recovery, so depreciation. The government has a bonus depreciation for renewable energy projects. Basically, if it's installed before the first of next year, there's a 50% bonus. During 2018, there's a 40% bonus, and then it drops to a 30% bonus in 2019, and then after that, it disappears or they'll have to reauthorize it. So information on that can be found at this link here. The others, there's a sales tax exemption for renewable energy. So if you're buying wood fuels for heating or any kind of thermal project, that you shouldn't have to pay sales tax on that. And so information about that project, that is at this site. There's also if you're involved with government, for state, local, or tribal governments, the federal government offers bonds to help pay for projects. So there's two types. There's a qualified energy conservation bonds, which is an older, I think that's the older program, and then there's a clean renewable energy bonds. So you could get on and find out about those two programs. But they're a way to raise funds to pay for a project. There were a couple other programs that have expired. I'm going to just highlight them briefly because they might come back. You never know. They've ended they were basically both aimed at combined heat and power. So when you're producing thermal heat and electricity. One was the business investment tax credit. So you had to pay taxes in order to take advantage of it. But it ended in the end of 2016. And I got the wrong date on this one. This one's renewable electric production tax credit. It actually ended last year as well. I must have been thinking about the current date and when I put that in there. But both these programs have expired for combined heat and power or biomass. Some of them are still on for wind or solar, but not for biomass. So, and I expect with the current administration, they're likely not to get reauthorized, but we'll have to see. So with that, that's the end of my presentation for today. If anybody has any questions, you could type them into the question box, or actually if you raise your hand, I might be able to open the mic. Let's see if I can see everybody here. Yeah, you might be able to I might be able to open your mic if anybody has a question. So the other thing is, if you there's this presentation I will put up on the Wisconsin Wood Energy site, and there was a previous presentation on wood energy systems that there's an older that I did last week, but there's an older version up on the site as well.